Today we're diving into the fascinating world of deep learning. Whether you're a tech enthusiast, a student, or just curious about artificial intelligence, this video will give you a clear and approachable introduction. We'll start by exploring what deep learning actually is, why it matters, and how it's shaping the future of technology. By the end, you'll have a solid foundation to understand the basics and appreciate the impact deep learning has on our everyday lives. Let's begin our journey into this exciting field together. Deep learning is a subset of machine learning, which itself is a branch of artificial intelligence. What sets deep learning apart is its use of artificial neural networks that mimic the way the human brain works. These networks are made up of layers of interconnected nodes, or neurons, that process data in complex ways. Deep learning enables computers to learn from large amounts of data, recognize patterns, and make decisions with minimal human intervention. This approach has led to breakthroughs in fields like image recognition, natural language processing, and more. Artificial intelligence has come a long way since its early days. Initially, AI systems relied on rule-based programming, where every possible scenario had to be coded by hand. Machine learning marked a significant shift, allowing computers to learn from data rather than explicit instructions. Deep learning takes it a step further by using multi-layered neural networks to automatically extract features and patterns from raw data. This evolution has made AI systems smarter, more adaptable, and capable of handling complex tasks that were once thought impossible. The heart of deep learning are neural networks. Imagine a network of nodes, each representing a neuron connected in layers. The first layer receives input data such as images or text. Each subsequent layer processes this information, extracting increasingly complex features. The final layer produces the output, like identifying an object in a photo. These networks can have dozens or even hundreds of layers, which is why they're called deep. The depth allows them to learn intricate patterns and relationships within the data. Deep learning models learn by processing vast amounts of data. During training, the model adjusts the connections between neurons based on the data it sees and the errors it makes. This process, called backpropagation, helps the network improve its predictions over time. The more data the model is exposed to, the better it becomes at recognizing patterns and making accurate decisions. This self-improving nature is what makes deep learning so powerful and versatile in solving real-world problems. Deep learning systems are built from several key components. First, there's the input layer, which receives raw data. Next are the hidden layers, where most of the processing happens. Each hidden layer extracts features and transforms the data. Finally, the output layer produces the results, such as a classification or prediction. The connections between these layers are weighted, and these weights are adjusted during training to optimize the model's performance. Understanding these components is essential for grasping how deep learning models function. Deep learning models can be trained in different ways. In supervised learning, the model learns from labeled data where the correct answers are provided. This is like teaching a child with flashcards. In unsupervised learning, the model tries to find patterns in data without any labels, much like exploring a new city without a map. Both approaches have their uses, and deep learning can leverage either depending on the problem at hand. There are several popular algorithms used in deep learning. Convolutional neural networks, or CNNs, are great for image recognition tasks. Recurrent neural networks, or RNNs, excel at processing sequences like language or time series data. Generative adversarial networks, or GANs, are used to create new data such as realistic images. Each algorithm has its strengths and is chosen based on the specific problem being solved. Understanding these algorithms helps you appreciate the versatility of deep learning. Deep learning is all around us, often in ways we don't even notice. It powers voice assistants like Siri and Alexa, helps recommend movies on streaming platforms, and enables facial recognition on smartphones. In healthcare, deep learning assists in diagnosing diseases from medical images. In transportation, it's used for self-driving cars. These applications show just how deeply integrated deep learning has become in our everyday routine. The medical field, deep learning is revolutionizing diagnostics and patient care. Algorithms can analyze X-rays, MRIs, and other medical images to detect diseases with remarkable accuracy. Deep learning also helps predict patient outcomes and personalize treatment plans. By automating routine tasks, healthcare professionals can focus more on patient interaction and complex decision-making. This technology is making healthcare more efficient and accessible. Self-driving cars are one of the most exciting applications of deep learning. These vehicles use sensors and cameras to gather data about their surroundings. Deep learning models process this information in real time, allowing the car to recognize objects, predict movements, and make driving decisions. This technology promises to make transportation safer, more efficient, and accessible to more people in the future. Entertainment platforms use deep learning to enhance user experiences. Streaming services recommend movies and shows based on your viewing habits. Music apps suggest playlists tailored to your taste. Even video games use deep learning to create more realistic characters and immersive environments. These personalized experiences are made possible by analyzing huge amounts of user data and learning what you enjoy most. Finance industry relies on deep learning for fraud detection, risk assessment, and algorithmic trading. By analyzing transaction patterns, deep learning models can spot unusual activity and prevent fraud. They also help banks make better lending decisions and optimize investment strategies. The ability to process massive datasets quickly gives financial institutions a competitive edge. Communication tools like email filters and chatbots use deep learning to improve efficiency. Spam filters analyze incoming messages to block unwanted emails. Chatbots understand and respond to customer inquiries, providing instant support. Language translation apps use deep learning to break down language barriers, making global communication easier than ever before. Deep learning is transforming industries and creating new opportunities. Its ability to process and learn from massive datasets allows for automation of complex tasks, improved decision-making, and the development of innovative products. As deep learning continues to advance, it will play an even bigger role in shaping the future of technology and society. Despite its many advantages, deep learning faces several challenges. Training deep learning models requires vast amounts of labeled data, which can be expensive and time-consuming to collect. These models also demand significant computational resources, often needing powerful GPUs or cloud infrastructure. Additionally, deep learning models can be difficult to interpret, making it hard to understand how they arrive at their decision. Data is the fuel that powers deep learning. The quality and quantity of data directly impact a model's performance. Clean, well-labeled data helps models learn more effectively and make accurate predictions. In many cases, collecting and preparing data is the most time-consuming part of building a deep learning system. That's why data management is a critical skill for anyone working in this field. Training a deep learning model involves feeding it data, adjusting its internal parameters, and evaluating its performance. This process is repeated many times until the model achieves the desired level of accuracy. Training can take hours, days, or even weeks, depending on the complexity of the model and the size of the dataset. Patience and careful tuning are essential for success. Once a deep learning model is trained, it's important to evaluate how well it performs. This is done by testing the model on new, unseen data and measuring its accuracy, precision, and recall. These metrics help determine if the model is ready for real-world use or if it needs further improvement. Continuous evaluation ensures that models remain reliable and effective over time. Two common problems in deep learning are overfitting and underfitting. Overfitting happens when a model learns the training data too well, including its noise and errors, and performs poorly on new data. Underfitting occurs when a model is too simple to capture the underlying patterns in the data. Balancing these issues is crucial for building models that generalize well to real-world situations. Deep learning requires significant computational power. Graphics processing units, or GPUs, are commonly used because they can handle the large-scale calculations needed for training deep networks. Cloud computing services also provide scalable resources, making it easier for individuals and organizations to experiment with deep learning without investing in expensive hardware. Deep learning community benefits from a wide range of open-source tools and frameworks. Popular libraries like TensorFlow, PyTorch, and Keras make it easier to build, train, and deploy deep learning models. These tools are supported by active communities, offering tutorials, documentation, and pre-built models to help beginners get started quickly. As deep learning becomes more widespread, ethical considerations are increasingly important. Issues like data privacy, algorithmic bias, and transparency must be addressed to ensure that deep learning technologies are used responsibly. Developers and organizations need to be aware of these challenges and work towards creating fair and trustworthy systems. Deep learning is a rapidly evolving field. Researchers are constantly developing new algorithms, architectures, and applications. As hardware becomes more powerful and data more abundant, deep learning will continue to push the boundaries of what's possible. We can expect even more impressive breakthroughs in areas like robotics, language understanding, and creative AI in the coming years. If you're interested in learning more about deep learning, there are plenty of resources available. Online courses, tutorials, and textbooks can help you build foundational knowledge. Experimenting with open-source tools and datasets is a great way to gain hands-on experience. Remember, the best way to learn is by doing, so don't be afraid to start small and gradually tackle more complex projects. There are many excellent resources for learning deep learning. Websites like Coursera, edX, and Udacity offer structured courses. Books such as Deep Learning by Ian Goodfellow provide in-depth explanations. Community forums and online groups are also valuable for getting help and staying up to date with the latest developments in the field. Starting with a simple project is the best way to learn. Try building a basic image classifier or a sentiment analysis tool using open datasets. Many tutorials walk you through the process step by step. As you gain confidence, you can experiment with more advanced models and tackle real-world problems. Deep learning community is vibrant and welcoming. Participating in online forums, attending conferences, and collaborating on open-source projects are great ways to connect with others. Sharing your work and learning from others will accelerate your growth and keep you motivated on your deep learning journey. Deep learning is a fast-moving field with new research and tools emerging all the time. Following leading researchers, subscribing to newsletters, and reading academic papers will help you stay informed. Continuous learning is key to keeping your skills relevant and making the most of new opportunities. As you explore deep learning, it's important to be aware of common pitfalls. Relying too heavily on complex models without understanding the basics can lead to mistakes. Overfitting, poor data quality, and lack of proper evaluation are frequent issues. Taking the time to build a strong foundation will help you avoid these problems and achieve better results. Creativity plays a big role in deep learning. Designing new architectures, experimenting with data, and finding innovative solutions to problems are all part of the process. Don't be afraid to think outside the box and try new approaches. Some of the most exciting breakthroughs come from creative thinking and experimentation. Collaboration is key in the world of deep learning. Many breakthroughs are the result of teamwork, with researchers, engineers, and domain experts working together. Open source projects and shared datasets make it easier to collaborate and build on each other's work. By working together, we can solve bigger and more complex problems. Deep learning is already making a significant impact in the real world. From improving medical diagnostics to enabling smart assistants and powering autonomous vehicles, its influence is growing every day. As more industries adopt deep learning, we can expect even greater changes in how we live and work. While deep learning is powerful, it's not a magic solution for every problem. Some tasks require more traditional approaches, and deep learning models can struggle with limited data or highly variable environments. Understanding these limitations helps set realistic expectations and guides you in choosing the right tool for the job. One of the challenges in deep learning is interpreting how models make decisions. Unlike simpler algorithms, deep networks can be like black boxes, making it hard to understand their reasoning. Researchers are developing new techniques to visualize and explain model behavior, which is important for building trust and ensuring fairness. Transfer learning is a technique where a model trained on one task is reused for another related task. This approach saves time and resources, especially when data is limited. Transfer learning has enabled rapid progress in fields like computer vision and natural language processing, making deep learning more accessible to everyone. Data augmentation is a strategy used to increase the diversity of training data without collecting new data. Techniques like rotating, flipping, or adding noise to images help models generalize better. This is especially useful when working with small datasets, as it helps prevent overfitting and improves model performance. Hyperparameters are settings that control how a deep learning model is trained. Examples include learning rate, batch size, and number of layers. Tuning these hyperparameters can have a big impact on model performance. Experimenting with different values and using techniques like grid search or random search helps find the best configuration for your model. Regularization is used to prevent overfitting in deep learning models. Techniques like dropout, L1, L2 regularization, and early stopping help models generalize better to new data. By adding constraints or randomly dropping connections during training, regularization ensures that the model doesn't rely too heavily on any one feature. Once a deep learning model is trained and tested, it needs to be deployed for real-world use. Deployment involves integrating the model into applications, monitoring its performance, and updating it as needed. Tools and platforms are available to simplify this process, making it easier to bring deep learning solutions to users. Deep learning is driving automation across many industries. From manufacturing robots to automated customer service, these systems can handle repetitive tasks with high accuracy. Automation frees up human workers to focus on more creative and strategic work, increasing productivity and efficiency. Deep learning is not just about numbers and data, it's also being used to create art, music, and literature. AI-generated paintings, songs, and stories are becoming more common, showcasing the creative potential of these technologies. This blend of technology and creativity is opening up new possibilities for artists and innovators alike. Researchers use deep learning to analyze scientific data, discover new drugs, and simulate complex systems. The ability to process and interpret large datasets quickly is accelerating discoveries in fields like biology, chemistry, and physics. Deep learning is becoming an essential tool for advancing scientific knowledge. Widespread adoption of deep learning is changing society in profound ways. It's improving healthcare, making transportation safer, and enabling smarter communication. At the same time, it raises important questions about privacy, employment, and ethics. As we embrace these technologies, it's important to consider their broader impact on our lives. We've covered the essentials of deep learning, from its basic concepts and key components to its real-world applications and challenges. Deep learning is a powerful tool that's transforming industries and opening up new possibilities. Whether you're just starting out or looking to deepen your understanding, there's never been a better time to explore the exciting field. Keep learning, stay curious, and embrace the opportunities that deep learning has to offer.